everyone. Thank you for coming early because really early back. I'm Kaushal. I'm a GlusterFS maintainer and I'm maintaining GlusterD. I'm a Red Hat engineer. I'm a current Red Hat and I work out of India, and I contribute to GlusterFS and Red Hat Cluster Storage. So today I'll be talking about GlusterD and GlusterD 2 mainly, but before that I want to give a quick intro to GlusterFS for anyone new to GlusterFS. And finally, if time permits, I'll probably do a GlusterD 2 demo of what it is right now.
So is there a possibility to adjust the mic?
Okay. Better now? No?
Just move it.
Hello? Hello? So this is just continue. Just to notice. Should I just stop this? Okay.
Okay, so I'm audible. This is better. So yeah, today I'll start be letting you know about GlusterD and GlusterD 2, what GlusterD 2 does do. And before that, we have a quick intro to GlusterFS or introduction to GlusterFS, just to give you an idea of what GlusterD does. And finally, I'll try to do a quick demo of GlusterD 2 in its current state. Okay. So, how many of you here actually know what GlusterFS is? That's good. But in any case, I'm just going to give a very quick introduction. GlusterFS is a distributed, scalable network file system with no central metadata server, or where you don't have a single point of distribution or a single point of failure. It has features for redundancy like replication, erasure, and others. It gives you the features of a pretty good storage system, enterprise storage system. We're trying to add in more features to make it really good. Okay. GlusterFS is POSIX compliant. This means that you can run any of your apps that you actually run on your normal backend file systems like XFS or XC4 on GlusterFS without modifications. You would probably want to do some modifications if you were to try some other distributed file systems, but not all of them. It's really flexible. We have a translator model of implementing the file system features, wherein each file system feature we talk about. So we have the distribution mechanism, we have replication, we have erasure coding. All of these are implemented as small bits of small modules. We call them translators. So we stack translators to get a GlusterFS volume with the features we want. Right? And you can access GlusterFS many ways. We have a native ARM protocol, GlusterFS protocol, and we also have integrations with a lot of other projects like Samba and NFS Ganesha, so that you can get Windows access as well as NFS access to GlusterFS volumes. And GlusterFS doesn't require any special hardware to run. You can run it on any PCs you have, or even on things like Raspberry Pis or your small single board computers. And just to help everyone understand some of the, these are some of the GlusterFS terms I'll be using. So first up, we have the queer node or server. This is basically just the computer on which you have GlusterFS server packages installed. A number of these GlusterFS servers together form a GlusterFS cluster storage pool. On these servers, we have bricks. Bricks is basically an entry directory or a disk mounted to a path on your server. which GlusterFS will export as part of its volume. And the volume is a logical collection of bricks on which finally you store the data of the GlusterFS volume. And how you store it depends on the kind of volume you create. And a GlusterFS client is any process that directly talks to GlusterFS bricks using the GlusterFS protocol, network protocol. Yeah, and I already mentioned translators. Right? So this is a general GlusterFS or a simple GlusterFS setup where you have servers on the bottom. These are all GlusterFS servers with GlusterFS installed. You got disks attached to them, those are our bricks. And now we got a native fuse mount, native fuse client, which directly speaks to the servers. And then we got a lot of other services which also talk to GlusterFS via GF API bindings. Let's see how we create a GlusterFS volume. It's really simple. If you want to actually go ahead and use it, you install GlusterFS server packages everywhere on the systems you want to actually, from which you want to create the GlusterFS volume. You do peer probes to set up your cluster storage pool. Peer probes are as in you just tell Gluster that this is the set of servers that you want to be using. Once you have your cluster storage pool, you create the volume. It's a simple command line. You would have to actually previously have done mounting your actual disks wherever required, but yeah, there's a simple command to create the volume. You start the volume and you're ready to use it. So it's basically 4 steps. You can do it. I don't know why I have this, but it's a really bad item, but yeah. So a volume, as I said before, is a collection of bricks running on different servers. Our volumes, right, we define them as server or translator graphs. So we stack translators on both the server side and the client side. So we have a client side graph and we have a server side brick graph. So all our translators create a graph out of them based on the volume create command you give, and then we stack processes, payments, basically using these graphs, and those payments behave as the graph specifies. So on the client side, most of our logic is on the client side. The server side bricks are basically dumb. They don't have a lot of logic there. All our distribution logic is in the distribute translator that happens on the client side. We have a ticket, again happens on the client side, and you'll actually have a tree not a simple graph like this, where from distribute you branch off to multiple branches, and from replicate you again branch off to get your features, to get replication, to get distribution, and similarly if you have ratio coding or striping or other stripe, those translators also will be present in the server side graph as on the client side graph. And the brick is just a simple linear graph right now, which has some features to help implement our process capabilities. Okay, so now, what is GlusterD then? GlusterD is the distributed management table for GlusterFS. This is what makes GlusterFS really easy to use, because it takes care of creating all those graphs. It takes care of starting all these processes everywhere, and makes it easy. Before GlusterD was present, GlusterFS user would have to write his own volume graphs called vol files, and you would have to distribute the files on your own, and you would have to start processes on your own. But with GlusterD you just have to write a simple command, and GlusterD does everything for you. GlusterD runs on all the nodes of the cluster storage pool and helps manage the cluster storage pool. So it helps you to grow a string. So you can do peer probes to expand your cluster storage pool, and you can do peer detaches to shrink your cluster. GlusterD manages volumes. By manages volumes, I mean it creates those graphs. So we have this volume graphs I talked about. It it starts those processes. It does elastic or dynamic expansion and shrinkage of GlusterFS volume, so you can do add bricks and remove bricks. And once you do expand or shrink, we need to rebalance data, so GlusterFS manages the rebalance process. It doesn't actually do the rebalance, but it manages all the daemons that provide GlusterFS features. It gives the clients the WAL files. You don't have to copy a WAL file from a server and put it onto a client. So GlusterFS client can just request GlusterD for the WAL file and it'll get the WAL file and it will mount. And it does a lot of other stuff. Yeah, managing a lot of other things. Okay, so now we are replacing GlusterD. Basically, yeah, trying to redo GlusterD. And why you want to do it is because GlusterD as it is right now is pretty bad. It's a big monolithic piece of code, unlike the rest of GlusterFS, where it has features in like small contained parts, which are translators you stack and get features you can extend easily. You can extend the file system part very easily. But GlusterD is a single monolith, and if you want to actually get any file system feature into the volume graph that we talked about, you'll have to mess with GlusterD to ensure that it generates graph with that particular translator. And doing that is pretty hard because it's really complex. I don't understand most of the code myself. So, yes, and someone coming in new will find it much tougher. And there are some problems with the architecture we have as well. GlusterD creates a mesh network between each GlusterD in the pool. So we got an n cross n squared connections in the network, and we have a concept of equal peers for GlusterD. That as in, you should we want to be able to do any of the cluster commands from any of the nodes in the pool. So we don't have a single leader there. So we try to do a lot of things to keep our store. Our store is what is our config database. We call a config database a store. It's basically back at GlusterD if you have to use GlusterD, and whatever is under that is our store. We try to keep this parallel GlusterD in sync across the cluster, and we do a lot of things to do that, which are complex and which lead to things like network floods in certain cases, and it makes GlusterD really hard to scale as we grow to a large number of nodes. And we want to fix this. Yeah.
What do you mean is large?
Large as in hundreds. So we do good in like tens of nodes. Once you go large, we have n squared connections, and every operation we do kind of reaches out to all the nodes in the cluster because we want to keep our store in sync. Yeah. So, okay, let's start with GlusterD. What's GlusterD 2 then? Or GlusterD next? Because I got comments yesterday from a person saying that he was confused about what is GlusterD 2. It's like a new version of what? No, it's not. It's the second attempt to do it. I just call it 2.0, giving it sort of a version feel because it sounds nicer. That's it. It's going to be the next management table for GlusterFS 4.0 whenever it comes out. Yeah, it's the new implementation of GD, where we attempt to solve all the problems we have, or at least try to. It's written in Go because it helps us concentrate more on our management problems rather than worrying about problems of C. It's being currently developed in a separate repository under the Gluster organization. It will finally move into the core GlusterFS source, but it's still moving fast and changing a lot, so we have it in a separate repository. We are doing preview releases almost every month now, so we have the latest release where you can actually create volumes and mount from GlusterFS clients, existing GlusterFS clients. So that's good. So let's go on to what we are doing with GlusterD. So currently, we're trying to build out the core of GlusterD 2. This is all the basic frameworks that we need to do our operations across the cluster. So we have things called transactions. Transactions are not in your sense of a database transaction or a atomic transaction. This is a, what do you say, you would more likely call it an orchestration framework where we want to do operations across the cluster. We want to do a plugin based architecture to keep cluster modular to help people actually implement features easily. And then we'll be implementing basic volume management and cluster management commands initially. So let's just basic creation of volumes, expansion into your cluster. It's like about 5 basic commands initially. We want to come out with the initial release in like the next 3 months and just figure out this basic commands are going to help us figure out how we have to design all the core features. All the other features like managing a lot of we manage a lot of other services, we have hooks, we have a lot of other things. So these things will come a little bit later. Okay, so yeah, so now let's move on to what we have actually done. So I talked about the store, right? We had a distributed equal store earlier, where we did a lot of things to keep that one particular directory is the same everywhere. But right now, with GlusterD2 or GD2, we are going to be using XCD like everyone else is now, and move our store problem across to XCD. We could basically use so we use XCD as a simple key value store where we store all our config and it's available to all members of the cluster. We do automatic setup of XCD clusters directly, so you don't have to set up an XCD cluster by yourself. So it's like we want to keep it as simple as GlusterFS is right now. When you install GlusterFS on all the nodes and you just do a peer probe and that.
Okay. Is this back again? Yes. Okay. Yeah, so we want to keep it as simple as GlusterFS is right now. You just install GlusterFS server packages on your nodes, and you do create a program, you can create volumes. You don't have to go ahead and do a separate setup of XCD. We handle that for you. We are currently embedded XCD within GlusterD2 so that you don't have to install XCD separately. But if you want, you will be able to use an externally managed XCD if you want. We want to do elastic XCD management as in, right now we have a very simple XCD or cluster algorithm where any GlusterD2 that comes up becomes an XCD2 server as well, and that doesn't really scale. So we want to have some elastic management there. Yeah, this is going to happen a little soon because I'm working on it right now. If you guys know about Purple Idea and this MGMT package, he does it. So I'm working with them to get that package out and make it reusable for everyone. Okay, and we have the orchestration framework or the transaction framework as we like to call it. This runs actions across the cluster. So the actions would be things like you want to create a volume. To create a volume, we do things like we check whether these directories are available everywhere, wherever required. So we check whether they are available. We check whether the peers are wherever required. Then we go ahead and create the all files everywhere, and then we do things like launch the actual big processes everywhere. So these are the things the transaction framework handles. So in the existing GlusterD, we have 3 different transaction frameworks. It's very complex, and all of the 3 are not flexible and they're just very rigid. And they don't really help write new patterns for managing stuff in GlusterD. So the transaction framework we are designing right now is flexible, and you will be able to do your own custom seeds of steps across the cluster. But again, James, as I mentioned right now, has some more has some thoughts about that, the way we do transactions, and so this is probably going to change before we do our final release. We have a payment manager in GlusterD. The current GlusterD, we manage payments. Okay, we manage like a lot of payments, and each payment is managed differently. Even though it's just starting a process with a wall file, we have like each payment doing their own thing. So every new person who wants to start a payment comes into GlusterD, writes their own code, and it's a mess. So if we do want to change something there, it's really hard. So we have a common payment manager package where ideally it would be as simple as writing a service file and like we do with systemd, and plus we would just launch that service, launch the payment, and it would just work. This payment manager also helps us communicate with the payments because we need to communicate with the payments to do certain actions. We want to do things like auto restart or have dependencies between the actual payments. These are things we are still working on and trying to figure out how to do it. With GD2, we have our management API is REST-based, HTTP-based, REST API. So in GD1, we use SunRPC-based API because GlusterFS itself uses SunRPC-based API and just use that because it's available. But this is not really usable for all other external projects who want to actually talk to GlusterFS and do their management actions. So we are giving a more universal HTTP-based API for all your management actions. So in the future, if you want to actually communicate with GlusterFS, do actions, you wouldn't need to run the Gluster CLI to do stuff. You could just directly talk to GlusterD and get actions done. There's still a lot of stuff to do. We have to actually define the APIs all properly. We need to formal specifications using one of these tools, Open API. We also need to figure out how we do auth and authorization and authentication for the REST API. Okay, so we also have gRPC in GD2. This is used for the communication between GlusterD tools where we do our transactions, right? We talk about transactions. So to do that, we use GD2. gRPC, for people who don't know, it's an HTTP2-based RPC protocol that uses protocols by default for encoding. It uses TLS by default, and that's good. We also will want to do plugins, and this is one of the possibilities we're going to use for communicating with plugins. We recently also implemented SunRPC. So this is a bit of a mess right now, but because we have 3 different RPC mechanisms in GD2, we finally want to reduce it to probably 1, and that would probably be gRPC. But so we did implement SunRPC to just allow ourselves to do the volume start and allow clients to mount volumes right away. Because we tried to implement gRPC in the C code base, and that was much harder than the SunRPC can go and lead us to that. We have better logging in GD2. We generally helps us trace actions across the cluster. So you'll be able to trace a particular operation throughout the cluster. It's a distributed operation, right? So without a proper logging, it would have been really hard for us to track an operation across the cluster. Now with structured logging, we add certain context to each log messages. So things like a transaction would add the transaction ID to any log generated as a result of the transaction. So you could track the progress of the transaction throughout the cluster. We still have to improve formatting a bit, but that's that. We still have a lot of stuff to do. Like I said, some of the stuff we have would be rewritten or redone again. We have stuff that is partially complete. We haven't done a lot of work on most of the things. We still need to write a lot of tests. We started out writing some unit tests, and we did a bad job of it, and so we are trying to not doing it. We need to restart it again and do it in a better way. And also we need to document everything that we do well. So let's talk about pluggability. I've been talking about pluggability a lot. But when I talk of pluggability, it's not just plugins that I'm talking about. It's a feature that I want to have with all the core frameworks of GlusterD. So like we have our transaction frameworks that itself is pluggable, so that's extensible and it is flexible, so you can write transactions of your own orchestrations of your own order. You don't have to depend on a particular order that we specify like that. Yes. Yeah. The aim is to allow external users to use those core frameworks without actually modifying the core frameworks and have these things well documented. So a lot of things require pluggability in GlusterFS. So yeah, translators need pluggability because when you have a new translator, you need to get it inserted into the volume graph. You need to understand or find out what options it has and to be able to set the translator options and other stuff. So you need to be able to add new commands because when you get features, you get a related CLI command or you need to be able to support that. So our CLI, our API should be pluggable to do this. As I mentioned, payment management should be pluggable, so it shouldn't be rigid. You should be able to easily start and stop payments as you wish. We want to do some sort of an event stream framework where you get events from GlusterFS, GlusterD management events. This is required by some of the management UI projects, say like over to manage GlusterFS, right? So they would be really happy with things like events where they get a bit going down, or you want to be created or something, we started stuff. That would help them a lot. Now, we also have actual plugins. We are still discussing two approaches. With Go 1.8, we have a native dynamic plugin support that is we have to investigate. But we originally wanted to do a sub-process plugin model where our plugins themselves are like child processes of the GlusterD and GlusterD and the plugins communicate over gRPC to get stuff done. This is still in discussion. Yeah, Volgen is one of the core parts of Gluster. So generating our graphs is really important. Generating the correct graphs is also important. Doing this is slightly hard. In GlusterD 1, we have this hard coded as a series of a loop over table translated that we have. So this table is hard coded in GlusterD, and yeah, that's not flexible. To change it, it's really hard. So we are designing a new flexible version where we want to do something like we have system service files. So each translator would provide a description file which says, okay, I have this translator, I need to be at this position in the graph. And a Volgen package is going to figure out where the translator needs to be when it builds the graph. Using the volume information that you provide. So when you do create a volume, you say, okay, these are the bits I want, these are the features I want. GlusterD, the volume package will take this information plus the translator descriptions from the files and build a final graph instead of having it actually encoded in GlusterD itself. So there's a POC progress. I'm working on it. This is still not merged into actual GlusterD yet. Yeah. We're also discussing events and hooks to allow things to happen dynamically. So yeah, events are like a stream of events which will help you like monitor the surface better. Hooks is we have hooks to actually right now say run certain shell scripts or scripts at particular points of execution of GlusterD. You can do actions like say on a volume start, our script right now manages NFS Ganesha or Samba configuration, right? So the GlusterFS provides tools to actually automatically set up NFS Ganesha or Samba shares when you create start or stop volumes. So we use hooks to do that. So we need to provide that as well. There are some problems with the current hooks mechanisms where they are problematic. We have deadlocks and other stuff, so we have to solve them as well. Again, this is in the planning. Okay. That's it, I guess. So, in addition to that, as I mentioned, we still need to do a lot of documentation and testing, write a lot of tests to make sure that we are accurate. So, questions? I do have a demo, but I don't think I have time to do it. Any questions?
You good about authentication or observation?
So right now we are using some RPC there, so we probably okay. Okay, so the question was, what are we doing about authentication between cluster and GlusterD 2? That would be between clients and GlusterD, right? So right now, GlusterD doesn't actually do a lot of authentication. We have DNS-based authentication just to know that that guy is a client that we know, but otherwise we don't do anything about that. Again, for client communication, since we are right now using RPC to do the same, but we still have to talk about that. If we do switch to gRPC has its own inbuilt authentication. You can plug in many authentication models into gRPC and you'll probably use that.
So considering you're switching to CD, I assume this means that the number of nodes required to develop
yeah, so okay, the question was, since we're switching to XCD, it would mean that the number of nodes we require, minimum number of nodes we require would increase. Yes, but we would still work in a single node fashion if you want to, or in a two-node setup if you want to. But even with GlusterFS itself, now we recommend at least a three-node setup so that you have sort of a quorum to avoid split trains. Right? If it is just a two-node setup, you are going to probably have split trains if something goes on. So, yeah, we will still work in the single node or two-node setups. We can do that. We do work in that. But it would be recommended with a three-node mode. Yeah.
Can you say something about the release schedule for?
Okay, so as I mentioned, we are right now working on the core features for GlusterFS, the GlusterD. So we expect this to be done in the next 3 to 4 months. Say, this is probably April, May timeframe. And we expect to complete everything to get feature parity with current GlusterFS before we actually do our successful about the release. So, yeah, we want to get the code ready so that we can start developing against GlusterD 2 instead of developing a specific one, all the new features that are coming. Okay, time's up. Thank you.